This video is a continuation of the KiCad Schematic register build. Let's get right into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
Okay, let's pick up where we left off at the last video. I need to create a 74 AHC 541 IC, and that really is going to be a copy of a 74 LS 541 chip from a pinning perspective. I want to create my own library, so I do create a library called ARIJUS, and I'm going to store that in there. Now, OBS, unfortunately, when I capture an application, it doesn't actually capture its child dialogues, so a bit of this was missed. You can see here that I was able to rename the chip to 74AHC 541. That's in the lower left-hand corner of that chip. And I also want to change the datasheet, so I went and grabbed that off of TI's website and put in a direct link. At this point, I realize the problems I'm having, and so I go back to a full desktop capture. At this point, I want to change all the 74 LS 541 ICs in the schematic to be 74 AHC 541 ICs. I fiddle around with this a little bit, having several false starts, but ultimately I'm able to identify that I can right-click on one of the IC symbols, and there is a change symbol option there. I go ahead and get that completed, and everything gets moved over. The challenge then is the labels are not lined up the way I want them, so I have to drag and drop them one at a time to the correct place. The next step is to find and put pin connectors onto the schematic. I'm not sure at this point if I want to go 16 pin wide or 8 pin wide connectors, but I'm rather certain that I do want pins, not sockets, on the actual breadboard so that I can get things hooked up the way that I want them to be. So I do a little bit of digging around and finally end up finding the connector that I want to use, which is a 16 wide connector. I start by placing this connector and then routing address bus 1 global connections or global labels to this connector. Notice that I am selecting an output connector, meaning that the signal is coming out of this pin header or junction into something else. This is incorrect, and I come back around later and correct that. And once again, copy and paste is my friend. Copy and paste for address bus 2. And now copy and paste for ALU buses A and B. Checking the naming I used previously. Now for the main bus. Now I need to create the line drivers and LEDs for displaying the current registered contents. I do this by copying address bus 2 and then start making the changes. Now in the last video I mentioned trying to use the grab feature versus the move feature. I do this moving the VCC line up to give me some additional room for the LEDs and for the resistors that are required, the current limiting resistors. And as you saw, that worked quite nicely. So I start by coupling a resistor and an LED together. I do make the mistake of hiding the value or the ohms of the resistor and end up coming back around to put that back in and place it within the resistor itself. You don't need those output connections anymore. Then once again, copy and paste works to my benefit here. So now I realize that I really want to put the value of the register on the schematic and on the silk screen later down the road as well. So I go back and make visible the first resistor's value and position it over the resistor itself in the schematic. And then I'm looking to see if I can find a way to do en masse, and I can't. So I start doing them one by one. Now with 4 resistors complete, it's far easier to copy and paste to update the others. Now for some quick cleanup, trying to create some space for some of the additional components. Next, I want to add a pin header for the control lines coming in. I need a 10-pin connector for that. It's at this point I realize that I'm setting out the sequence of these control lines incorrectly. and it's something I spend a little bit of time on through the rest of this video, making sure that I have that sequence correct. While I'm at it, I'm going to go ahead and place a power and ground connector. 2 pins. It takes me a minute to figure out exactly how I want to place power and ground. At this point, I realize I have several mistakes, one of which is the output of the register contents should not be displayed red, but rather should be displayed green. So I work on correcting that first. And due to the length of this video, I move the additional corrections to the next video. Next, I place a 74 AHC 541 line driver for driving the control signal LED output. I start with one. I'll correct that in the next video. And now I change the colors back to red. In the interest of time, we'll leave the video there. There's lots to do still. I do have to fix the control LED output. I have them wired up in KiCad as if they're active high. They're really active low, so I need to make changes for that. And there needs to be a second line driver, and I need to separate those signals. It's already been done, but again, in the interest of time, I've cut this video short. I do have it all recorded. So expect that to come out shortly. And then just overall complete the KiCad register circuit design. And then I've got some basic sanity checks. I'm not sure if I'm going to do those on camera or off. Things like counting ICs and making sure that I get them all, because I have a bad habit of missing things like that. I do still have some work to do on the clock, troubleshoot the single step bounces, Again, that's been done. I just need to do the fix for that. And then I've got a couple of other things that are parked related to the clock. Again, I do want to get into the opcodes and operations so that we have some context for some of the things that we're going to take on in the near future. And then I do still have to add a line driver to the bus input test harness. Thank you. We'll see you again soon.